Hi everyone, this is Devansh. I have been working on a project in cybersecurity field since 6 weeks, and this video is all about what I have learned in this 6 weeks. And I have chosen a topic to be fileless malware analysis. To get a basic idea, I have referred a base paper which I mentioned here. The problem statement of this project is to design and develop a technological solution for detection of fileless malware, and we have chosen the solution to be a desktop app. This is the contents of the project. The first and foremost is abstract. This is an overview of the project. In recent years, the massive development in malware industry has totally changed the landscape of attacking from file-based malware to fileless malware. So we propose a detection technique based on feature analysis using machine learning for fileless malware detection. You would be getting in doubt what is this file malware is all about. Malware is nothing but an intentionally made software in order to disrupt the already existing programs in your computer such that one can steal sensitive data, disrupt the operations and cause damage to your system. There are two types of malware basically. One is file-based malware, other one is fileless malware. And in this project we'll deal with fileless malware. Fileless malware never leaves any residence in the hard disk. It all deals with random access memory. These are some of the indications of fileless malware. Once if your system is being affected with a malware, you could observe an increased memory usage and an unusual traffic around the system, and an unexpected browser behavior, and changes in registry entries, a huge number of pop-up ads. And this all things can be done using a RAM dump. So we collect a RAM dump or a memory dump from the user. And how do the system get infected? There are like two scenarios. Scenario number one, on clicking on a benign file without unknowingly a suspicious or malicious script would be running in command prompt. And the second thing is on visiting a malicious website, on getting in touch with the unclear JavaScript code, a malicious script would be running in the command prompt that all deals with the RAM. We couldn't see that. We couldn't find even. So these are some of the tools that we have used in this project. One is AWS, which is a cloud that we use to store our input data from the user. FTK Imager, we have used it to obtain the memory dump of the system. VMware, it is to analyze manually the features of a memory dump. Volatility, it's like heart of the project. It's the main tool. It has a plugins, built-in plugins, which could extract the features from a memory dump, which is the basis for the ML prediction. In the PyQt, it is a graphical user interface app which will put make a desktop app to it. And this is a flowchart based on scenario one. It has two things in it. One is feature analysis, another thing is machine learning. In feature analysis, we take input from a user as a memory dump. Once it is taken, it stores in Amazon S3 bucket, and in EC2 instance, we take that memory dump and we analyze using volatility. Once volatility is being done, the obtained features has been set as test data, and it's being given to a trained model. The second phase is machine learning model. How to make a model using machine learning? We have to take a data, we have to divide it into it is being split into test data and trained data. Using trained data, the algorithm is being trained. Once it is done, we give the test data and check the accuracy. If it is found to be 1, then the model is ready for prediction. And all these steps happen to be automated by using bash script or AWS Lambda. And these are few important works in the project. One is the ML algorithm, choosing an ML algorithm that is random forest based on 93.33% accuracy, and the snapshot for memory dump with an extension of VMEM or VMSM, and a volatility tool to obtain the features, test data, that is to give to ML model for the prediction, ML prediction to check to tell whether it is a banner or malware, and GUI. All this working on this 5 step is being done by us, but the GUI, putting all these things to be automated in the GUI has to be we are working on it actually. And our app is finally, like, the output is a app. So I would like to show our app based on, I'll explain the things based on this flow chart. First of all, I'll open my PyQt code. I'll try to run this. The interface is being opened here. The first step is input. We can give any kind of input. Actually, a VMU file has to be input, but it takes too long to upload. So I'll take a text file and just open that. So it has to be open. Before, it has only one file, that is bg.gif file. If I refresh that, this here is a final test2.txt which have just given us input. It is being stored in S3 bucket. Once it is being stored as S3 bucket, we take this into a EC2 instance and we try to analyze on this. This is the EC2 instance. Let me check what does it actually contain. ls translate is a Linux command, and if you can check, it has a volatility 3 tool in it. So I'll just open this before I clear the screen once. cd volatility, enter, let's say what are the files in it. If you can observe, there's a VMEM file, so I'll try to apply my commands to a few commands to obtain features out of this test1.vmem. There are actually 44 features that we have to set, so there are automatically 44 commands. Here are the commands. Here are the commands. Here are 44 commands over here. I'll try to open one of the command over here. So there. To change the VMEM file. This text1 and enter. Showing an error. It is test1, sorry, not text1. In test1, I got a number called 36, and this is the number of processes that is being running in that test1.vmem memory dump. So I have to collect all these numericals, and having already collected it, and I'll show you them. The next step is collecting the data into a test data and the machine learning process. This is the data set I have. This is the machine learning thing part. This is the data set that I have been used, that is sophisticated -malmem 2022. This is the data that is being used. It has a class called Bannon and malware. It shows Bannon samples, malware samples based on this attributes. If you can observe there, the pslist.nproc is one of the attributes, and it is one of the plugin in the volatility too. So that's why I have chosen this as a test data set. I mean the data set that is being used for test and training too. And it has almost 58,000 samples in it and 57 columns, and this is not necessary. I just dropped it, and I also dropped few other attributes which are least important to the output prediction. I have dropped all these things, and after dropping, if you can observe, there are only 45 columns here, and these are the updated columns list. And I have taken the total data into X and Y. Y I have considered only the class which I have shown there, Bannon and malicious. This Bannon or malware, that is the output. I have taken that as Y call, and all other attributes is being taken as X call. And I have the data into train and test data. And let me check on the last row, taking the last row. If you can observe here, it has the last row answers to be malware. If we get malware, then our model is predicting proper. Here is malware. It is being taken as last row. And I have shown you earlier that in EC2 instance that we had to collect the numericals. I have collected numerical of a cridex.vmem. These are all the respective columns, and their values is being taken in this first. I have taken an array, and I made it into a data frame, and I predicted using random forest algorithm, and I found it to be malware, and cridex.vm is a malware sample. And same that I have taken a snapshot VMEM of one of my virtual machines, and it is a Bannon. I didn't infect anything into that virtual machine, so it is shown to be Bannon. So from this, we can conclude that yes, feature that is being obtained using volatility, storing it in an array, and once it is given to a random forest, it is predicting it is either Bannon or malware. So we will display this answer on the app, either Bannon or malicious, once we click on result. So on clicking input, we store the input into a S3 bucket. On clicking analysis, the stored S3 bucket file, the volatility is being uploaded on this file, and features is being abstracted. On clicking on result, we'll show the result. I have made it automate to store the file in S3 bucket, but automation analysis and result has been worked on. We are working on it, and this is the documentation of my app That is, welcome to Fileless malware analysis tool. It has three features. One is input button, analysis button, and a result button, which shows the file is either abandoned or malware. The status of the project is it is ready to load the first feature, that is taking an input and storing it to an AWS cloud. And the approaches to complete this other features are we're working on the AWS Lambda to complete the second feature, and ML algorithm. It means automation on it. And Team SDD is working, and we'll try to complete it by the end. And moreover, if you would like to know what we have did in every week, we have a agile process over here. It has all the sprints. Sprint 1, it shows about the week 1 task. Sprint 2 shows the week 2 task. Sprint 3, Sprint 4, Sprint 5, Sprint 6. It all shows what we have did in every week. I'll just put this in the description. If you would like to know about what we have did in this week, please do refer to that. Thank you. Thanks for watching.